Other math fans going to do another review question about how we work with vectors given 2D information. In particular, how do we turn a slope into a vector? This is something we talk about in the first few days of the course, and then it always pops up later. And people ask this question, and I appreciate they ask this question on the discussion board. It's a popular question because they're reading my solution to an old exam problem. We found the slope so this question says, basically find a vector that is parallel to the tangent line. It's a 2D question, so let's kind of talk about the question a little bit. They give this function. In order to be parallel to the tangent line, we need to know what the tangent slope is. And since they're talking about when x is 3, we plug in a 3 here, and we get that the slope is -2. But the question wants that in a vector form. And the vector I chose to give in my solution was 1, -2. And that's when I always get this question. Where did the 1 come from? Now, I addressed this the first time we saw it, but again, it just sort of pops up out of nowhere. What the heck is going on? So, here's what this is about. We think about vectors. How I teach vectors is as changes. This is the change in x. This is the change in y. The reason we talk about vectors is when we get to 3D, you now have 3 quantities, and you can't just take 2 and make a slope. There's not a good way to put the 3 together, so we leave them as separate. The moment you leave them as separate, it allows you choice. Okay, so let me say something here. If you have a line that has slope -2, I ask students to say, what does that mean? And usually students will say, well, it's the rise over run. I go, well, what does it mean in the picture? Well, it means if you go over 1, you go down -2. And then I say to them, where did your 1 come from? And that's the answer to the question. What I mean by that's the answer to the question is if you want a vector that has slope -2, then you're looking for something where the rise over the run of your vector is -2. Now, there's an infinite number of fractions where you divide 2 numbers and get -2. So there's other correct answers. Like I could use 7 and -14. That would be correct. You put a -14, you put a 7 here, that's correct. The question is only asking for any vector that points this way. It doesn't say, well, it does say how long it needs to be, but you could initially make it longer or shorter. You could even make it point the other way. Like you could say, I'm going to have it be -3. So if the denominator is -3, then this has to be 6. All of these are vectors that are parallel to slope -2. Okay, so now let's actually read the question and see what it was asking. It said to find a vector that has length 4 and is parallel. So it's saying, among all of these vectors, can you find one that's length 4? Now, maybe we got lucky. What's the length of the first one? Well, it's the square root of 1 squared plus -2 squared, which is 4. It's the square root of 5. Oh, shoot, that's not quite 4. So then you keep trying. There's a cleaner way, and it doesn't matter which vector you start with to rescale your vector. And that's what you're seeing in the solutions. I chose to just use this one. If you instead choose to use this one, that's perfectly fine. Turns out you're going to get the same answer as me. Because when you rescale, you divide by the length. And when you divide by the length, it'll cancel out any decision you made, so to speak. So I divided by the length and to make it a unit vector, and then I multiplied by this. But the reason there's a 1 is because I chose it to be a 1. You can pick whatever you want here. But the moment you make that choice, this number has to be -2 times your choice if you want the thing to have slope -2. So whatever choice you make here, I would recommend you choose 1. Maybe I shouldn't say that. If someone said I wanted a vector that had a slope that was a fraction, so someone says I want a vector whose slope is 7/3. You could do 1 comma 7/3. That is a vector that's parallel to this. I think I would prefer to do 3, 7, because that avoids fraction. So both of these would be correct here. Usually we just pick 1 comma m, wherever m is the slope. This comes up in several problems. In the homework, there was a problem where you had to take information from a curve and find two vectors and then find the angle between them. And so we've had a few questions where you had a slope and you had to turn it into a vector. Okay, that's probably overkill, but I hope that helped.